Here's our first lesson on matrix operations. So the first thing we need to do is define what is a matrix, and that is it is a rectangular array. And our example here, we have basically it's a spreadsheet of numbers, almost like a Google spreadsheet or a Microsoft Excel spreadsheet, where we kind of have this array of numbers. So we have rows, so row 1 and row 2, and we have columns. We have rows and columns that make up any matrix. So we have 3 columns, but we have 2 rows. In fact, we define the size of a matrix. So in that case, let's say we had 1, 2, 3. So here's our matrix. And our matrix is made up of 2 rows and 3 columns. So anytime you define the size of any matrix, it's the number of rows by number of columns. So in this case, we have a 2-row, 3 columns, so a 2 by 3. Okay, so that would be, we would call that a 2 by 3 matrix. All right, so next thing, we're going to just jump right into adding and subtracting. And pretty self-explanatory, but the first thing is you have to have same size. So if we have a 2 by 3 and we're trying to add another matrix, the only matrix size that would work is another 2 by 3 matrix. When you do that, you end up with another matrix, a third matrix as the resultant, which is going to be the same size. What you do is you take the corresponding entries. So by the way, every number in a matrix is called its entry. So each of these entries, we take corresponding entries. So an example, we take entry in the top left of each and we add them together. So 2 plus 2. And that'll go in that first entry of our final matrix. And then let's go across. So then we have 4 and 6. So 4 to 6, 4 plus 6, and 5 plus 7. Okay, and so on. So we would do that for all of them. 6 and 0, 9 and 9. You get 4, 10, 12. All right. So based on that process above, it says, can you add the following 2 matrices? Well, I already discussed this, but I don't have corresponding elements or entries between the two. So I have a 2 by 4 and I have a 1 by 5. That is not, so anytime we cannot do our work, we just say that the operation is undefined. Okay. So on your own, you can do a couple more examples here. Subtraction, it's the same thing. So same element minus same element. So 4 minus 2, 6 minus 5, and a half minus 7. Okay. Same thing, you're just going to take 3 plus 4, 8 plus 2, 9 plus 3, and so on. So just for the interest of time, I'm going to skip those for now. I think this should make enough sense. If not, just rewind the video and watch the first one. The rule is add corresponding entries. And the big thing to note, matrices must be the same size. Okay. All right, the other thing we did in lesson 1, we did scalar multiplication. So if we turn our page to page 2, we have scalar multiplication. It's just like, so let's say we had 2 times x plus 3. Okay, so here we have a binomial times a scalar multiplier. So that would just be 2 times the first element plus 2 times the next element. Same thing is going to happen here. We're going to take negative 2 times each entry. So negative 2 and 3 is negative 6. Negative 2 is 4. Negative 2, 5 is negative 10. And negative 2. Pretty straightforward. If you had a fraction, doesn't change anything. 6 times 2/3 is 4. This is negative 10 thirds, and then again 4. 2/3 times 3/4, that's 6 over 12, so that's actually reduces to a half. Anything times 0 is 0, and then that's 20/3. It doesn't reduce. So in general, our rule here is you go cursive so it doesn't mess it up. Okay, so anyways, our rule says multiply every each entry. Sorry, entry should be in there. Multiply each entry by the scalar first, because we may have 2 times a matrix plus 3 times another matrix. We may be asked to solve something like that. And the idea is take 2 times your matrix here, get a resulting with your 2 inside, and then distribute that 3. Now take matrix A and add it to matrix B. Okay. The other thing we did in that first lesson, it just says solve for x. So we can see that entries 3 and 2 gives us 5. Here we have x plus 8 equals this entry, so equals 2. So x must be negative 6. Same thing down here. Negative 4 and 5 is 1, but 7 plus y equals 3. So y is equal to negative 4. And then the same thing is going to be, x plus 1 equals 4. So x must be 3. y plus 7 is 1, so that must be negative 6. And our z term, z plus 9 is 3. So negative 6 plus 9 is 3. Okay, so that was just more practice. It's getting you used to, we'll use that a little bit later in a more complex series of steps, but just getting you that idea of being able to match them. So stopping this video here. That is everything for our first lesson.